fairly recent thing in our company. I would time it maybe April, May. What we do is encourage input from everybody in the organization, even straight through engineering, the HR department, operations. So this project that came up is actually to deal with a concern that actually happened on the operations side. Our product is what Phil over here is assembling right now, just a small aerial vehicle. The design happens in plant as well as the manufacturing. So this project, once again, is the flight chamber project, and it's a working operator stage. Second team, myself, Say Long, I'm a manufacturing engineer for the operations group. Phil Cervoni and Tom Mooney are both part of the operations team. So the problem was that the flyer testing procedure was producing far too much noise. It was about a peak of 101 decibels. And the problem here is that the operations can't stand beside the fixture to properly monitor the test. Meetings were affected by noise in many parts of the building. And team members in the cafeteria were even affected from the constant white noise. If you look in the diagram there, the test room is the red spot. Operations floor was seeing about 84 decibels, and the cafeteria was about 75 decibels. I'm going to try this video and see if it works. Okay, so the video doesn't work, but what that was going to be was the flyer noise as it was taking off. So instead, I'm going to fly that one right there. Guys, stand back. So how does this noise stack up? We have our painful levels between 150 and 120 decibels. You have your jet planes taking off, your fireworks and such. Your extremely loud portion, this would be MP3 players at your max level, model airplanes, gas lawnmowers, then comes the Aeryon test chamber, followed by hand and pneumatic drills, and subways. Getting a little lower, you're into your very loud portion, between 80, 90 to 70. This is where the Aeryon cafeteria was sitting, right in between busy traffic and low drivers. So why is there so much noise? So if we break down the problem, the test room had a very high ceiling with a loud echo. There was no insulation. It was located in the center of the building, and there were up to 4 systems in the same room, and it was a large and mostly empty room. So the first thing we were focusing on was the fact that it was located in the center of the building. Okay, so you can see on the left, this is the room where the chambers were, and that's like you said, 19-foot high ceilings, no insulation, so very loud. Right beside was the office space and the lunchroom, so you can imagine what they go through eating lunch, trying to talk to your friends. Basically, you'd say he's very upset for having to wear these earmuffs. And here's the earmuffs we had to get, which was an immediate corrective reaction. So that was, they could muffle up to 30 decibels. So that, for a couple days' work, nobody likes to wear them for 8 hours per day. So basically, the target was to reduce noise levels near the Aeryon test chambers to below 80 decibels. And to reduce the noise levels in the rest of the facility to below 65.
So next is countermeasures. How do we reduce this noise? So we have 3 options. The first is a dedicated soundproof chamber, similar to what you might find at a theater out there. This one obviously is very costly. It takes quite a long time to complete. The second option would be to have a contractor come in. You can see it's still very costly. Find you a little bit quicker. It's still very costly. And the third option, the one that we ended up deciding to go with, was to have some team members build a flight chamber in-house ourselves. So we did it, and here's And here's an example of the finished product after marketing helped us put the finishing touches on it. So now you can see that the location of the test room is in the back of the warehouse, away from the cafeteria. After measuring, we also made it so that only one flyer is in the chamber at each time. The ceilings are 10 feet as opposed to the 19. And just the area space itself is just dedicated for one flyer per room. When we did some measurements, we were able to reduce the sound in the cafeteria to 62 decibels, which is basically just your speaking voice. And then doing some measurements right outside of the test chambers themselves, we were able to reduce it to 84 decibels. We went even further than that, and we got some convoluted acoustic foam. We lined literally every surface we could in one of the chambers to test its performance to see how we did there. We were able to lower it further 4 decibels just outside the flight chambers. We also added a webcam to the side so that the test operators can monitor tests without having to leave their station, and just making it more efficient